Hi, Dr. Shivery. So I'm calling on my phone right now, so I'm sorry if it's not as clear as it's supposed to be. But so basically, I feel like from activity one, we were supposed to prove the Ohm's law, and we used the simulation in order to do that. So I took the light bulb, I took the ammeter, the battery, and another wire, and connected all of that to form a loop. So basically, we get a current flowing. We will get electric current. And then I did change the resistance to the 38 ohms. And I put the voltage meter over to see what was the value. And so for the current, I wish I could show you like when I had first did it, because I changed it once we went over to the other one, but I had got 0.24. And then for the voltage, my voltage, it came out negative, of course, because you have the negative charges flowing through, which you could see. Wish I could have flipped the camera, but you could see those negative charges flowing through. So of course, this is once I changed it, but of course you would get the negative voltage. I'm sorry that it's like opposite. I wish I could switch the camera, but for some reason once I start taking a video I can't do that. But yeah, for the current I got 0.24, and then for the voltage I got negative 9 volts. And yeah, so then I went through and I made the different potential differences. And so I did 20, well, negative 20, and I did negative 20, and I got 0.53, and I did negative 40, I got 1.05, I did negative 60, I got 1.58, did negative 80, got 2.11, and I did negative 100 and got 2.63. And so once I got that, I basically went and did my graph, as you can see here, and it turned out to be a linear line, which was a good thing. I'm sorry, my computer did something weird. Which was a good thing because as we discussed in class, I remember Dr. Gasseller saying that if we had a linear plot, then that means that it obeyed the Ohm's law, and also once I put up the slope, I saw that my slope matched the resistance, which also shows that it obeys the Ohm's law, because basically the slope line is basically is resistance. So of course those values should be equal to each other, which shows that this whole simulation did obeys the Ohm's law, and proves that his equation was right. And it also proves the relationship that is between the voltage, the potential difference or voltage, the resistance, and the current, which is that the potential difference across the resistor is directly proportional to the current flowing through the resistance. So that's how we get the equation for Ohm's law, which is V equals I times R. And then also, just let you know, I forgot to erase this. Also, just let you know, for my resistance I had 38 ohms, and then for this I had negative 38, which of course I had negative because I put it in negative numbers. I could have put it in positive numbers, but I mean I wanted to keep what my voltage meter showed, which was negative, as I showed you with the negative 100 one. And that was my last one, like when I was doing a different when I did the different potential difference in currents. And also I did a potential difference in currents by changing the voltage of the battery. So that's how I was able to change to get those values. And so yeah, so then basically that kind of answered, because it said compare it. So when I compared the resistance and the slope, it was basically the same, and because the slope line is equal to the resistance, and my equation, my slope was negative 38, my y-intercept was 0.0725, and basically showing that is directly proportional. The potential difference and the current are directly proportional. And so yeah, I basically found that relationship. which was proved also by plotting my graph. And so then for activity 2, we had the different trials. With basically it was the different lengths. So for my first length, I had 1.6. The potential difference stayed constant throughout the whole thing. That was 10.5. And then my current and resistance that changed. So I had got 0.37, and then in order to obtain the resistance, I took the equation and rearranged it to where I got is equal to the voltage over the current. So for resistance for 1.6, I got 28.4 ohms, and then I did 2.7. Like I said, potential difference was constant, so I got 0.21 for the current and 50 ohms. Length 3.4, potential difference constant 10.5, 0.18 for the current, and I got 58.3 for the resistance. For length 4.3, I got 10.5, current 0.12 voltage, and I got the resistance of 87.5. And then for the last length, I got 5.4. I'm sorry, I was saying my numbers so wrong. 5.4. 10.5 is a constant. Current is 0.11, and then the resistance was 95.5 ohms. I'm saying all these numbers, but I mean, I'm also going to send the graphs too, so you will actually see, you know, what I'm actually saying and see the values and see the actual graphs better. But I was just saying it like as far as video purposes. But yeah, so basically, so like when it was 1.6, then we had 28.4, then when it came 2.7 for the length meters, we had 50 ohms, and then it was 3.4, we had 58.3 ohms. And so basically we're telling that the relationship is directly proportional, because obviously as the length is increasing, the length of the wire is increasing, the resistance is also increasing as well. And that is because that the electrons, this was something also that Dr. Gassel was talking about in class, so I'm also kind of using our lecture knowledge. But he was telling us how, like, basically when describing the relationships, that this would be true because the electrons collide with ions more as they pass through. So that would of course increase the resistance. And yeah, and so I mean, I don't know if you want to see the graph for that, but I also had this graph for it. Those are my values, and then here's the graph of my resistance versus the length. And so yeah, basically we know it's directly proportional. We know it's increasing, and that's because electrons collide with ions more as they pass through. And that's it. This lab was actually good. It was I was a little nervous. I mean, doing it by myself, you know, just as far as like checking purposes, like, am I right? But I mean, I feel like it was pretty good. And I hope you like the video. I tried probably not to make it too long, because I know you probably got other videos to watch. But yeah, thank you, Dr. Shivery. Have a nice and wonderful weekend.